This question is given in GATE 2006. Now see this question. In the circuit shown below, okay, the switch was connected to position 1 at t equal to t less than 0. Now see here, this is the circuit where this is the switch. For t less than 0, it is connected to switch 1, like position 1. Now at t equal to 0, it is changed its position to 2. Now at t is equals to 0, it is changing the position to 2. Okay, assume that the diode has 0 voltage drop and storage time is Ts. For 0 less than t less than Ts, Vr is given in the volts as. Okay, if you understand the question properly, then you can know the half of the solution itself. Okay, you will get a complete idea how to solve that question. Now they are saying is for t less than 0, the switch is connected to position 1. Now exactly at t is equals to 0, it is connected to position 2. Now I will draw the timeline diagram for this, explaining this question. Okay, now let us see, this is the timeline diagram. This is exactly at t is equals to 0. Okay, now you see here, this is the timeline for minus t and this will be plus t. Now for t less than 0 means this portion, right? For t less than 0, it is connected to switch 1. When it is connected to switch 1, it is plus, it is minus. So current is flowing in this direction. Okay, so the diode will be in forward bias. So the diode will be in forward bias, which means conducting state. Conducting state. Okay, so no issues. Vr will be, that is I into R, that is 5 into 1 kilo ohm, 5 volts, plus 5 volts. Okay, now what they are saying is, when this is connected to position 1, now exactly at this position, it is connected to position 2. Exactly at t equal to 0, it is connected to position 2. Now what happens is, now current is flowing from this minus to plus. Okay, so which makes immediately the diode will be in reverse bias. Okay, so at this point, the diode has to transit from forward bias to reverse bias, right? Okay, but immediately it will not change. It will take some time so that it will go to full reverse bias mode, that is steady state reverse bias. Steady state reverse bias or full reverse bias we can say. So it will take some amount of time to move into full reverse bias. That time is given by TRR, that is recovery transition time. Okay, recovery transition time, and it is the sum of transit time Tt plus storage time Ts. Okay, now if you observe from T0 to Ts, this will be called storage time. In the meanwhile of storage time, it will remove the excess of minority carriers. Okay, it will take removal of excess minority carriers. Excess minority carriers. Okay, now from storage time to transit time, we call this as Tt. It is the position at which it will go from this forward bias to reverse bias. Okay, this is going from forward bias to reverse bias. At this point, it will be full reverse bias where Vr is equals to 0 volts. Now at this point, exactly position 2, he is asking what is the value of Vr. Now if we calculate at this point, first we need to calculate current. Current is equals to V by R. Voltage is minus 5 volts by resistance is 1 kilo ohm. That is equals to minus 5 milliamperes. That is the current exactly at t equal to 0. Now we need to find voltage Vr at t is equals to 0. So Vr at t is equals to 0 equal to I into R, that is equals to I is nothing but minus 5 milliamps into R is nothing but the resistance value 1 kilo ohm. 1 kilo ohm, that is equals to minus 5 volts. Okay, that is the required answer exactly at t is equals to 0, Vr voltage. Okay, if you see the options, it is option A, Vr equal to minus 5 volts. Okay, the only thing you should know is it is having some time, reverse recovery time. TRR stands for reverse recovery time. It is the sum of this transit time plus storage time, and this storage time is nothing but used for removal of excess minority carriers, and transit time is nothing but the point at which it starts reverse biasing to the complete reverse bias. It is the sum of these two, so it will take this much amount of time from going from conducting state to non-conducting state. Okay, the answer is -5 volts.